This is a case study on how I use the Euclid Data Explorer to, well, explore some Euclid data. I always find that I learn the most amazing things about how to use our tools when I try to use the tools to do real science. Now, in this particular case, I'm just going to own the fact that I am not an extragalactic astronomer. If you haven't already figured this out from the movies that I make, I study things in our galaxy, so I am not a primary user of Euclid data. But collaborators of mine are educators, and they came to me and said, can you help us get some resolved galaxies out of the Euclid data that we can use to give our students to do labs with? I thought, yeah, let's see if we can figure this out. Let's see if we can work together to figure this out. So we did some searching in ADS, and we found this journal article, which talks specifically about looking at the fraction of barred spirals in these galaxies in the quick release data, so the public Euclid data. And it's an interesting paper. They're training their machine learning code on the galaxies that have already been classified in the Zooniverse. And once they train their code on that sample, then they've let it loose on the Euclid data to try to classify the galaxies, the resolved galaxies that are in there. And they're using that to understand something about galaxy evolution. Well, in the context of what I'm doing here, I don't care so much about the galaxy evolution. What I'm really interested in is getting the subset of targets that were resolved galaxies out of the Euclid Q1 data release. So from this paper, we can go and look at it and try to figure out what it is that they're doing. So it turns out, I admit I didn't read this paper in tremendous detail, but it turns out that what they're doing, all of the parameters that they're generating, is actually part of the regular Euclid data release. So we can go to the Euclid Data Explorer and see what we can find. So we need to go to the Inspect Objects search. Now remember, this is giving you a view of the whole sky, and the yellow is what is planned to be observed, and the red is what it has been released. And remember that if you can't remember the difference between the on and the off, you can have it fill. So the yellow is what's planned to be observed, and the red is what has been released. But I can't see through the yellow when it's filled, so I'm going to go back to that. I'm essentially going to stab randomly, see what we can find. So I'm going to go search. While it's loading, I'm going to remind you that I'm also kind of stabbing in the dark here. So the first time I did this, I searched on images, which isn't what I want. At this point, I want catalogs. So Inspect Objects is what I want. Now, if you just stab randomly in the sky, almost everything that you're going to find is not necessarily going to be a resolved galaxy. We've picked a random part of the sky here. Most of these things are not resolved galaxies. So there's 13,000 and change sources here. But what we're going to need to do is get access to the catalog from the Euclid data release that has the morphology information. And the morphology information is not in the main catalog. The morphology information is in this catalog. And remember that the only catalog that is ARIA and DEC is that main catalog. So in order to get the useful morphology information out, the first thing we need to do is figure out how to get access to this catalog. So let's go back to the results tab. We've got 13,000 sources, but there's no way that all of them are resolved galaxies. Our chances of finding resolved galaxies goes up quite a bit if we focus on the brighter sources. So if I limit this to just the brighter sources, just as a starting point, maybe that's too bright. Let's go to maybe just greater than 100 microjanskis, because that's mostly stars. So let's go greater than 100 microjanskis. Let's see, are we getting most of the galaxies this way? Still mostly stars. Let's see. What about the fainter ones in this list? I clicked on the heading twice so that it's sorting now by reverse. Still mostly stars. Okay, so less than 100 and greater than 1. Let's see, is that going to get us galaxies? Still stars there. How about less than 50? Still stars. How about less than 1 and greater than 0.5? Now maybe galaxies. We've got 600 sources, maybe greater than 0.75, just to make it a reasonably short list. Okay, 179. So now I've got a short list of 179. I can go over to Euclid catalogs, and I want to search in the morphology catalog, but I can't do a spatial search because there's no RA in DEC. What I want to do is an object ID search. So I need to load the object IDs from a table, but I want it to use one of the only table I already have loaded, which I've filtered down to have only 179 rows. So I want to use that, and the object ID column is ID, and I want to match it against the object ID column that is here, and then I want to search. So now it's going to give me the matches for this 179. So now it's giving me all this information about the morphology of the galaxy. But is this really going to be useful for finding the most interesting galaxies? Like, would a kid be interested in classifying that galaxy? That's probably not going to be terribly useful for the average kid. Here they're talking about 7,771 barred galaxies. And if you get into this even further, you can see that there's talking about a short list of targets. So it turns out that they start originally with about 300,000 galaxies, which is, of course, just a tiny subset of the galaxies that are found in this quick release data set. But those are the ones that they can use for this galaxy morphology study. So probably those 300,000 galaxies are going to be a good place to start. So look for things that are going to be interesting enough to hold the attention of a kid in high school astronomy or in Astro 101 in college. So the next thing we need to figure out is how I can do a search to find those interesting sources, and stabbing blindly at the sky is not going to do it. They say in the paper that they have published the 300,000 galaxies they care about in this Zenodo repository. So if we go to this Zenodo repository, they have published the catalog in a couple of different formats. They've published it in CSV format, which is comma-separated values, so that you can read it in an Excel file. But they have also published it in Parquet format. And Parquet format is a format that is really good for very large catalogs, and it is something that the IRSA tools can understand. So let's see if we can find where they've put the morphology catalogs. Let's see, where can we actually download it? Let's find the link here. Schema, documentation, useful measurements. Where is the Parquet download? Oh, here we go. Morphology catalog Parquet. So I'm going to download this Parquet file. It's not going to take too long. You see how, the CSV file is much larger than the Parquet file. The Parquet file is a much easier to transport version. So now let's go back over here, and instead of the Euclid tool, let's actually go to IRSA Viewer and then upload. And now I'm going to go find that downloaded file that I just downloaded that's in Parquet format. All right, so 380,000 sources as promised. Now, the first thing that tripped me up the very first time I did this is kind of sneaky. So the IRSA tools are used to seeing a column called RA and a column called DEC. And it's used to using that as the right ascension and declination. For reasons I don't understand, and I don't know why, because I admit I have not read this paper in detail, this catalog has arrived with columns called right_ascension and declination, which are clearly the actual positions. But then separately, they also have a column called RA and DEC, which is like weirdly truncated. I think it might have something to do with the way that the Parquet files are bundling and handling the partitioning of the sky in an efficient fashion. But what that means is, even though it looks like it's plotting the RA and DEC properly, it's really not. It's plotting these quantized versions. So the first it took me a long time to understand this the first time that I did this, and I thought that our tool was broken. So that's why I'm highlighting this for you, because it kept me going for a while. Because there are 380,000 sources, it is not showing each and every one on the coverage map, even if it understood the positions properly. But it's understanding the positions approximately well enough that we should be able to filter this down, because for what we're doing, we don't need 380,000, at least to start with. We might eventually. But I'm going to just pick a chunk of sky, again, essentially randomly, and I'm going to filter this down. Cannot display requested data. Well, that's new. Okay, let's cancel that filter. Okay, let's do this a little differently. Let's do right ascension greater than 100 and declination. You see how it's quantized? It's already doing some funny things. Okay, so we're down to 135,000 here. Let's do declination less than 65. I'm just trying to get it down to a reasonable number. 39,000 is still a lot. Less than 60, let's see, 64, 12,000, 63, 63.5. Okay, 2,600. Still a lot, but okay, that's reasonable. So now I've got this catalog. I can take this catalog, and now I've got this list of object IDs. So I'm going to save this truncated thing. Let's do truncated galaxies. And I'm going to save that. So now I've got this list of object IDs. Now I can go back to the Euclid tool. You go to the Euclid catalogs. Again, I want to do an object ID. So instead of the uploaded tables, I want to upload the file that I just saved, the truncated galaxies. Load table, and again, I need the object ID. Position doesn't matter, and I want to bounce it against the object ID here. So there's all the morphology parameters. We still want the images though. So now we're actually going to do something funny, because remember, it's confused about the RA index. So we're going to go back to the main catalog, which does have RA index, but we're still going to match against object ID, which is kind of funny. Let's get all the fluxes columns and do the object ID match again, and then search. So now this is the main MER catalog, which has the right positions, but I'm matching it against the object ID from the table that I used. And now it's pulled the images for me. So now we should be able to scroll through this list, and all of these galaxies, they should all be bright enough and big enough that they were resolved enough to appear in this journal article. So it's still going to need some curation, right? Before I can just set high school kids or Astro 101 kids loose on this collection of galaxies, I'm still going to need to do some curation. I'm still going to need to do some cleaning up, some careful selection of certain number of spirals or barred spirals or ellipticals. So I'm going to need to actually read this paper and figure out what all these parameters mean. I'm going to need to figure out how to understand what all of these columns mean. And to help me with that, if you go to the Details tab, each one of these rows is really long. This is a vertical view of one of these horizontal rows, and you can see the description more easily. If you put your mouse on top of the column, it will give you a pop-up that tells you what that is, but here you can see the long form description. So I find it easier sometimes to be able to look at these descriptions so that I can understand a little bit better what all of these parameters are. So you have then a short list of things with the morphology classifications, and this table will give you the cutouts. So once you have the subset of galaxies that you know you're interested in, you can select the individual objects. Then you can actually download the images and actually then use them in a lab that you are preparing for your students to actually classify the galaxies. Turns out you don't actually have a generate download script button that appears here. Turns out that's a bug. It does show up here. So here's how to get around that bug if you're trying to do this before we get around to fixing the bug. What you want to do is, again, create a table of the short list of things that you're interested in. Let's say I just want those 3. I can filter it down so it's just those 3. Now I can go back to inspect objects. I can do multi-object, upload table, and then I want to pick out of the loaded table the one that has the 3 in it. Use that as my target. And I don't want to do 360 arc seconds. Let's use 60 arc seconds. Search. And now I have something that's going to load properly with just those 3 targets, and it will give me the prepare download script choice. So there, it's got generate download script. So now you can download the thumbnails once you have that. But you see it, I used a fairly large search radius. So if you want to get just the thumbnails just around your designated target, you should use a smaller search radius than I just used.